I'm Dr. Andy Kaufman, recovering physician, plandemic whistleblower, natural healing pedagogue, and legal code talker. You can call me the Truth Doctor. I'm here to shift your paradigm as I perform a radical forensic dissection, discerning fact from fiction, science from pseudoscience, medicine from poison, law from legal fiction, and individualism from collectivism. This is your channel for unraveling the truth about health and science. This is the Healthy Living Livestream. Hello, everyone, and welcome back to the Healthy Living live stream. I am your host, Dr. Andrew Kaufman, and I am coming back after a week of vacation, which was much needed, but I am fully energized and ready to go. I hope everyone enjoyed my Healthy Living Highlights episode last week, so that in case you missed any of my most popular episodes, there were excerpts there that you can go back and because they were really excellent and well received. Today, I'm going to talk about another topic that has gotten very, very popular, and there is much research to discuss, which I will call red light therapy. But before I go there, let me just tell you that unfortunately on the platforms like we're watching now, there is a lot of censorship, and my content continues to be heavily shadow banned and removed if I speak on certain controversial issues. But inside my True Living Fellowship, there is no censorship at all. We have complete free speech, and I can present my monthly masterclass and answer monthly Q&A questions about any topic, even those that would get me in trouble on these platforms. So please take a look at the True Living Fellowship and consider becoming a fellow today. And now on to today's topic of red light therapy. Now, this is a type of treatment involving exposing you to light, which could be in the visible spectrum in the red color range, or into the infrared spectrum, which is right next to red on the spectrum chart. And I'll show you that in a few moments. Now, this type of treatment has many names. And if you're going to look in the primary medical research literature, you're going to find a variety of different terms, such as LLLT, or low energy or low level laser light therapy, and also photobiomodulation, sometimes referred to as PBM. Those are the most common terms. In the lay literature, like in various wellness websites and magazines, you're more likely to see red light therapy or infrared light therapy. Now, when it comes to the research on this, there are several issues that are problematic in order to make an educated opinion. First of all, many of the studies are looking at outcomes that are not necessarily relevant. For example, they're looking at molecular markers like cytochrome, enzymes, ATP, or subcellular structures like mitochondria, but these don't necessarily translate into meaningful clinical outcomes like, improvement in your muscle strength or improvement in your vision if you have an eye disease, for example. So for this presentation, I'm going to focus on the clinical evidence with these more definitive, meaningful outcome measures, and I'm going to ignore all the sort of basic science research. Now, when we look at the clinical trials, there are several difficulties of how to conduct these trials appropriately, and I'm going to get into some of that as I go through some of the study results, but let me just point out that there is no standardization of exactly how to administer this kind of treatment. The light sources can come from different technologies and are pretty much either LED, light emitting diode sources, or lasers. And the energy output of the light is highly variable. The frequency of the light is highly variable. And also how the beam is constructed, like does it provide diffuse light, narrow beam, like a laser, etc. So there are a lot of different variables that make it challenging to draw clear conclusions. Now, there also are many accounts of various scientists trying to hypothesize mechanisms involved that may improve various clinical scenarios, but all of the research has pretty much missed the most important relationship to physiology, which involves structured water. And I'm going to talk about that in more detail. And they simply are looking at different targets, although they do acknowledge, at least at a certain frequency range, that the infrared light is absorbed by water, but they don't discuss water as part of the mechanism that may be involved in some clinical improvement which has been found. So I'm going to kind of start with some basic information about electromagnetic radiation and take you all the way to the red light therapy and what the clinical evidence shows. So let me bring up my slides here. Now Okay, so this first slide shows the different wavelengths and corresponding frequency ranges of the different types of electromagnetic radiation. And we can see in the middle row of this chart is visible light from 400 to 700 nanometers in wavelength. That's the length of those light waves. And on the high end of that, in the 600 to 700 range, is red. And that is the frequency of light that's involved in these treatments when visible light is used, and that is usually from an LED light source. Now we could see the infrared starts at 700 nanometers and goes technically all the way up to 1 millimeter, although the wavelengths that are near 1 millimeter are generally not always considered infrared, and these are the terahertz waves that are used in body scanners, which I'll describe in just a moment. And we can see that if we go beyond 1 millimeter of wavelength, we're in the microwave range. And we know that microwaves also are absorbed by water and cause water to heat up because they're very high energy. But that's not what we're talking about in this treatment. I just wanted to give you an overview of what it is that we're talking about with this light and infrared light therapy. Now, here is a paper from MIT Technology Review, and they're really reporting on research in the primary research literature, including the famous or infamous study from Los Alamos National Laboratories about terahertz waves, which is the type of radiation used in body scanners in the airports that you can opt out of a variety of ways. And if we just read from the subtitle here, it says, a new model of the way terahertz waves interact with DNA explains how the damage is done. Now, if you search this on the internet, you'll actually find many articles that are fact check type articles saying that the research doesn't show that terahertz waves damage DNA. But it clearly does. And even MIT Technology Review, a mainstream journal or magazine, acknowledges this finding. And in the text, it says that the terahertz waves unzip double-stranded DNA, creating bubbles in the double strand that could significantly interfere with processes such as gene expression and DNA replication. So we can see that this is pretty seriously harmful. And the reason I brought this up is mainly to distinguish this range of waves, of electromagnetic waves, being outside of the technical infrared, but somewhere closer to the microwave spectrum, is distinct from what we're talking about in these treatments. But I also want to highlight that depending on what wavelength of radiation you use on someone, there can be very different effects. And if we look back at this chart here and go up toward the top, we see X-rays. And we know X-rays are toxic and can cause cancer, right? And they are also electromagnetic radiation, but in a very different wavelength. They have extremely small wavelengths and very, very high frequencies. Okay, so now that we have a general understanding, I want to introduce the topic, or reintroduce it hopefully to most of you, of the fourth phase water, or EZ, exclusion zone water. And this is a different state of water which is highly prevalent in our bodies and highly involved in our normal and healthy physiology, where water can actually separate into charged species like hydronium ions, H3O+, for example, and OH-, although the actual structures may be slightly more complex than that. And that when there is a hydrophilic surface, like in this case, it usually uses Nafion in these experiments, but you could see there's a surface in the diagram, that it causes a separation of charge in the water, and that any particles or solutes in the water is excluded from the charged area near the surface. And this is very key because this is what happens in all the membranes in our body and all the barriers, like in the blood vessels, at the cell membrane, at the mitochondrial membrane, and on, and is very important at establishing the electrical potentials, which is a charge difference on two sides of a surface or a membrane, that drives many of our functions at the cellular and molecular level. Now, it turns out that what actually causes the charge to be separated in water is largely due to infrared light and some visible light. And this was kind of discovered in Gerald Pollack's lab by accident, but further research shows this. So on this diagram, which is from the book, The Fourth Phase of Water, we can see that on the x-axis here, we have the exclusion zone size, but the ratio to the size before they shined the light on it of different frequencies. So you can see that, for example, this 2 here, if you get up to a 2, it means that you doubled the size of the exclusion zone. So this means that you increased the amount of structured water, or perhaps increased the energy or coherence of the water, which is thought to be a very good thing for our physiology. And it's been established, for example, that many toxic substances shrink the size of the EZ zone. So this is the opposite of a toxic substance in terms of how it affects the exclusion zone. And we can see that if we look on the left side of this chart, in the visible spectrum between 200 and 700 nanometers, that we do see up to a 2.5-fold increase in the exclusion zone, which is very positive. And that so happens to be right in the red light frequency range, which is what is used in a lot of the red light therapy. Now, if we look further to the right in the infrared band, we see even larger increases in the EZ zone. And this is more profound because the energy of that light was much, much lower, because the light sources available couldn't produce the same intensity of the light. So the dashed line at the top is a extrapolation of what might have occurred if it was full strength infrared light. And we can see the peak frequency there is, or wavelength, is 3,000 nanometers. And that's a key number to remember. And if we do infrared absorption spectroscopy on structured water, we'll see that the maximal infrared absorption occurs at 3,000 nanometers. So that's where you get the maximal increase in the exclusion zone, which should be the optimal benefit in terms of the structured water and potentially our physiology. So that begs the question, what frequencies do they actually use in red light therapy? So I found this study which reviewed many studies in the literature for a variety of different parameters, including the wavelength of the light. And here are the data tables which show in the second column the wavelengths in each individual study. Now we can see lots of numbers in the 700s, 800s, and 600s in this table. And in the next table, we also see numbers as low as 420 and then all the way up to almost 1,000 nanometers at 980. And that is pretty consistent with everything I've seen in the many studies that I have looked at in this space. So up to about 700 is considered in the red, from 600 to 700. And then 700 up to 1,000 is considered infrared, and it's also called the near infrared spectrum. But they never have looked at wavelengths of 3,000 nanometers in any of this research, unfortunately. So that is likely because none of the authors of these studies have made the connection with structured water and how this might actually likely work. Now, let's shift into the actual clinical studies and keep in mind that it is possible, if this higher wavelength longer wavelength were used to maximize the effect on the water, that there might be superior clinical results. So I certainly advocate for studies to be done in the future like that. So I'm going to review several different review articles and meta-analyses where they looked at large numbers of studies, like they combed through the literature, found everything that they could find on that subject, and then applied some criteria to try and weed out the low quality articles. And this one looks at two particular clinical situations: tendinopathy, which is disease of the tendons, and like tendinitis, or, like, for example, tennis elbow or golfer's elbow would be a common one, and there are many other kinds, or plantar fasciitis. And these are often considered overuse type injuries. And what we found here is that they did a meta-analysis, which is where they combine the raw data from a number of studies into one data set and do a statistical analysis. So there are a lot of sources of error, but this is more powerful than looking at each individual study, because you're sort of equalizing them so you can look at the outcomes with everything else roughly being equal or standardized. And I'm going to give you a number of these forest plots. So on the right-hand side, you'll see this vertical line with all these horizontal dashes across, and then these diamonds. And this is called a forest plot. And each one of those horizontal lines represents an individual study. And the vertical line in the middle reflects no effect of the intervention. So here we're talking about light therapy, and anything that crosses that vertical line actually demonstrates that there's no clear benefit. If the line is completely on the right side, then it favors light therapy. And if it's completely on the left side, it means that light therapy could be detrimental. Now, this looks at pain results. Okay, so pain is the outcome measure it's looking at in people with these types of musculoskeletal injuries. And it's looking at it immediately after the completion of the therapy. Now, you can see that there are three groups of studies because they had different methods. So the top group is the light therapy versus placebo. And this is the most important method to use because it really isolates the effect of the light therapy. And in most of these studies, as a placebo, they used a sham light therapy. So they actually had a device that they put on people. And in most cases, it actually was put out visible light, but it was not in the right spectrum for the treatment. So in the treatment group, it had light in the right wavelength, and in the sham placebo group, it had light of a different wavelength, or perhaps really low energy. And you can see that almost all of the studies in that group cross the vertical line. And that means they don't show any clear benefit. And in fact, there are 4, 5, 6, 7 studies that cross the line, and then 3 that are on the right showing a benefit. Now, as we go down to the next group, the light therapy versus another intervention, we see that there are more studies that are on the right side out of the whole. A higher fraction are to the right side showing a potential benefit. And then on the third group, the light therapy versus no intervention, we see that all the studies showed a benefit. Now, this is what we're seeing here is a placebo effect, that the subjects most likely believed that this device was doing something and therefore they had a benefit versus getting no device or nothing. Whereas when they had a sham device, there was really no clear difference between the treatment and the control group. So this really supports the conclusion that for pain, there is no real benefit to the light therapy from this data. Now, if we look at the next forest plot here, which looks at pain result at follow-up versus right after the therapy, you can see that the benefit now disappeared. So the more time out, the placebo effect faded, and now you're seeing the studies not showing a clear benefit even when they're compared to no intervention. And we're going to get similar results when we look at disability, okay? Where you can see that almost all of the studies cross the vertical line regardless of the comparison group. And furthermore, when we look at longer term disability, we only see one isolated study, which it compared to no intervention, where there seems to be a benefit, but it has a large degree of error, and that's why that diamond is so wide. So in other words, looking at this data, and I'm just going to skip the next slide because it shows the same thing, for tendinopathy and plantar fasciitis, we don't have a very convincing evidence of any benefit whatsoever. So let's now look at a meta-analysis for running performance. And this here on the right is another forest plot, although it's a little bit more cramped than the ones we just looked at. And you can see that every single study crosses the vertical line, and there are even one that's to the left of the vertical line. So I would say for running performance, there is no clear benefit, at least using the methods that were used in this study. And here we have a study looking at muscle tissue and performance in strength training. And this is a different kind of display. And here what we have are these different squares. And if the squares are blue, the study showed a positive effect. If the squares are red, there was no effect in the study. And if they are gray, there's an ambiguous effect. And what you can see here is that about half the studies, or I'd say maybe about 30, 40%, there's no effect, 30 to 40%, there's a positive effect, and the remainder, there's an ambiguous effect. And if this study looked at it not just for quadriceps, but also for biceps and a couple of other parameters. And essentially it was the same in all the categories, that there was a mixture of studies that showed no benefit and some benefit, and others that were ambiguous. And ambiguous might be that there was a benefit right after the treatment, but then it faded at the next time point, for example. Now, if we also go and look at it for macular degeneration, it's a little bit more interesting. Now, I could not find a meta-analysis on this topic, so we're left with review articles. which is just a qualitative description of the studies that were available, but without a statistical analysis, so we won't have any of those fancy plots. But in the results section, the authors quoted the available studies on photobiomodulation and age-related macular degeneration demonstrated promising but inconsistent results. So it seems like a very similar outcome to what we just looked at in exercise, muscle strength, as well as pain related to tendinopathies. But if you look at the details, there are quite a number of studies that all reported a substantial improvement in visual acuity in patients with macular degeneration. Now, for those of you who may not be familiar, macular degeneration is a retinal disease that is generally said to be age-related, and as it mostly occurs in older people, and it can result in loss of vision, which can get worse over time. So if this improved visual acuity, that is certainly significant, although some of the other parameters they looked at didn't always improve. And there were also some problems with the methods that they use. And I think the authors were being very conservative, but this is the most promising data that I've seen in terms of a benefit from red light therapy. Now, I saved the best for last, and I want to caution you that this slide represents only one single study. So it's unique from the other papers I presented that were analyzing, dozens of studies and trying to find everything that's out there. But this was just one particular study, but it was a well-done study, even though it had a small sample size. And I was quite impressed by the numbers here. And this is looking at patients with dementia, and it's looking at a number of different cognitive tests before and after giving light therapy transcranially. So in other words, to the brain. Now they have to use the infrared light for this because the visible red light will not penetrate deep enough to get into the brain. So they're using the infrared light. And we have here in the table at the bottom, the first line, MMSE, stands for Mini Mental Status Examination. Now, that is a standardized test that is administered, one for screening for dementia, and then also can be administered serially over time to assess the progression of the dementia. And it's a test that I've administered thousands of times in my career as a psychiatrist, and you can score a possible 30 out of 30 points. So if we look at this table, on the left hand, it shows with the control group that got sham light treatment, and they had a mean mini mental status score of 23.2 before the treatment, and then 24.6 after the treatment. And according to the statistical analysis, that did not represent any difference. So they essentially had no change in their mini mental status exam. But if we look at the group that got the light treatment, they started off 22.8, right? Almost the same as the control group, but they gained an average of about 5 points, which is quite significant. In fact, even puts them over the cutoff score to say they have dementia, from clearly dementia to no dementia in terms of the mini mental status. And it was a highly statistically significant increase. So the fact that this is only one small study, I think there were about 43 subjects in the treatment group, makes me want to be very conservative with how I interpret this. However, it is quite significant of a result. And because there is almost no risk of any adverse effects from this type of therapy, I think it's pretty reasonable to at least try this in someone with dementia, clinically, and see if they do improve. And it would be even more interesting to look at people with more advanced dementia, because even these beginning MMSE scores were not very low. They were more early, mild dementia type numbers to see if there can be improvement with more severe cognitive decline. All right, so I have talked quite a bit about light therapy, but of course, this is not an exhaustive presentation of all the research because there are thousands of papers out there. And this type of treatment approach has been looked at for other conditions. There are a lot of studies looking at various skin conditions. Many of them are cosmetic issues, but also some skin pathology. And there are other areas of investigation that they don't have quite as much data on yet. So I wanted to just pick a few interesting areas that seem to have, the most benefit and then seem to have no clear benefit whatsoever. So I think you can tell that I'm not fully sold on red light therapy as being overall of a benefit. And one of the main reasons I'm skeptical about this is that more than half of the sun's energy is put out in the infrared spectrum. And we are exposed to infrared light all the time. It penetrates through pretty much everything. You would have to put yourself in a special chamber that blocks out infrared light to avoid it. So since we're already getting this light from the sun, what exactly is this therapy doing? Is it simply intensifying our exposure to something natural, which would enhance the natural benefit of it? Could we achieve the same results by simply getting more direct exposure to the sun? And what about if we increased the wavelength up to 3,000 nanometers? Would that mean that we would get a much more demonstrable benefit of a more significant magnitude? So I think if you're suffering from a serious irreversible eye disease like macular degeneration, if you're suffering from dementia, in addition to the other approaches that you're taking, I don't think this is a bad one to add because it may just provide a substantial benefit, and the chances of any adverse effects are practically zero. So I would say don't spend thousands of dollars necessarily because you can probably find high quality devices. Most studies show that the higher frequency ranges, more in the near infrared, are more beneficial for most of these more serious health conditions. So I think that should arm you with some good information to make a reasoned decision. And you can see that red light therapy is definitely not a gimmick or a sham, but the research is a little bit misguided and a little bit limited to know exactly how beneficial it may or may not be. All right. I hope you've enjoyed that little presentation, and I'd be happy to take a few questions if anyone has one. So we have one from John Catledge. I most often see RLT recommend for neuropathy treatment. Any comment? I'm not sure who or what RLT is, but I did not look specifically at treatment for peripheral neuropathy. So I think what I would recommend, if you go to PubMed and put in as a search parameter either LLLT or photobiomodulation and peripheral neuropathy, you'll find any research on that topic, and hopefully you'll be able to interpret it according to the same kind of guidelines as you saw me interpret these other studies during the live stream today. All right, Dana Jones asks, are there any benefits from red light therapy applications to restore hair loss and stimulate hair regrowth? I believe there may actually be some studies on this. I know there are studies on looking at stimulating collagen deposition in the skin. So this could be a possibility, but I have had some success with hair loss and have another approach that works really well. And it essentially involves using bentonite clay paste on the area of hair loss, like on your scalp, to detoxify the hair follicles, and supplementing with collagen-rich foods and perhaps a few other things depending on what type of hair loss it is. So you can certainly look into that and consider a consultation with me if you'd like to learn more or get the full protocol. All right, Caitlin Jensen asks, so is it possibly more beneficial to people up north with little sunshine during winters? Well, there may be something to that. Possibly. I would have to look up the difference in infrared light, because infrared light is a little bit different because it penetrates through everything. So there's no shade from infrared light like there is from visible light. So it may, in fact, not make as much of a difference, but still may be worth a try. All right, Julia Mock asks, does it help with detoxing of heavy metals? Not that I'm aware of. There's no literature that I found on that, and I wouldn't necessarily think that would be a primary mechanism. But if we do think about how it may work on water by increasing the exclusion zone, that may help push contaminants or toxins out of the structured water, and our body may be able to excrete them more easily with that kind of a stimulus. So there certainly is a possibility of that. But I have looked at heavy metal detoxification in depth and even have a terrain workshop on heavy metals that goes into more detail and includes a full protocol how you can use natural chelators to remove heavy metals from the body. So I encourage you to check that out. All right, I think we can do one more question. We have Amba Stapleton asks, what is the difference between far and near infrared? So near infrared is generally considered between 700 up to 2,500 nanometers of wavelength, which is awfully close to that 3,000 nanometer mark that I talked about, where water is maximally improved from infrared light. So I would say, though, that anything from 2,500 up to near a millimeter would be the far infrared range. Well, those certainly were some interesting questions, and there's a lot to think about when it comes to this topic. So keep doing the research. Let me know what you find, and I look forward to seeing you next week for another Healthy Living live stream.